Okay, so we're going to do some more examples here. So what I'd like you to do is solve for x in each of the following. Again, recalling that I want you to actually pause the video before we venture any farther afield so you can actually try these examples. So please solve for x in this scenario. So imagine that this side was 20 and this side was, I guess, let's say 12. So go ahead, pause the video and solve for x just to make sure that we're good. Okay, welcome back. Recall, of course, we're going to use Pythagorean Theorem. C squared equals a squared plus b squared. And then we're going to recognize that this side over here has to be side C, and these two could be either a or b and a, doesn't matter. So we're going to get 20 squared equals 12 squared plus x squared. We're going to then solve. I'm going to move this over before I evaluate this time. So we're going to have 20 squared minus 12 squared equals x squared. So that's going to be 400 minus 144 is equal to x squared. So that's going to be x squared equals, and that's going to be 256. We're going to root both sides, root this side, and we're going to end up with x is equal to the square root of 256. I'm pretty confident that's 16, but let's just check that really quickly. So go over here, and we're going to do 250. Oh, actually turn it on, I guess. Hello. On. Okay, it's not going to work like that. Let's do it like this. So 256 square rooted. And we're going to then check and see that it is in fact, yeah, of course it's 16. So we're going to come back here and say 16, which is great. All right, so we're going to have 16. So let's try another one. How about if we had, oh, there we go, a line tool. Much better. Here comes another right triangle. What I'd like you to do this time is I would like you to find both the area and perimeter. Okay, so imagine that this side was 17 and this side was 6. Okay, and so I'm just going to give you the instruction I want area and perimeter. So take a moment now and see if you can find those. You can go ahead and pause the video. Okay, welcome back. So area, well, I remember that the area of a triangle is equal to base times height divided by 2, and the perimeter is super easy. It's just side 1 plus side 2 plus side 3. So we've got those formulas at our disposal. That means that we're going to need base and height for area. Well, we've already got base. That's base right there. And this is going to be the height over here. So what I'm going to need to do is obviously solve for this side. So I'm going to assign an arbitrary variable. I'm going to just call it x. And so we're going to use that to actually go ahead and solve for that. So we're going to have that 17 squared is equal to x squared plus 6 squared. So I'm going to evaluate that. So I'm going to grab my calculator and we're going to do 17 squared. 17 squared is going to be 289. Okay, so we're going to have that 289 is equal to x squared plus 36. Lob that 36 to the other side, so we're going to have 289 minus 36 is equal to x squared. And so I guess that would be 253 is equal to x squared. And we're going to root both sides, so root this side, and we're going to find out that x is equal to, I'm going to have to grab a calculator to do that one. So we're going to go to a second function, square root of 289. Oh, nope, 253. So second function, square root of 253. And we're going to find out it's 15.91. So I'm going to come back here and know that it's 15.91. So that is what the height of that triangle is. So if I want to find the area is equal to me base, which is 6, times height, which is 15.91, divided by 2. So I'm going to grab my calculator and we're going to do that really quickly. So we've already got the height right there. So I'm going to multiply by 6 and then divide by 2. we're going to find out that the area is 47 point, what was it, 772 units squared. Okay, all good. And then for perimeter is just going to be the sum of the sides. So 6 plus 17 plus 15.91. So I'll grab my calculator again. And we're going to have that is 6 plus 17 plus 15.91. And we find out that it is 38.91 units. So where are we at? 38.91 units is the perimeter. Okay, so that's some basic review of Pythagorean theorem. We've been doing Pythagorean theorem since grade, 6 or 7, so we're in good shape on that. So now what we're going to do is we are going to learn, or I guess because you guys are grade 11, we're going to revisit SOHCAHTOA. So SOHCAHTOA is, of course, our primary trig ratios. Okay, so let's think about what it takes to be a primary trig ratio. First things first, this is only going to work, so it's only useful for right triangles. Okay, this is not something that we can do on any old triangle. It's gotta be a right triangle. Okay, and so let's think about what a right triangle is going to be here. So we're going to have our right triangle. Here we go. There's our right triangle. Okay, right triangle. And so we can only use the primary trig ratios on right triangles. So you have all seen this before. And so the general form of this is going to be sine, cos, or tan of the angle, and the angle is usually going to be called theta, is equal to, and I'm going to put up the way that I teach this, so it's going to be the first letter over the second letter. And so you might wonder what the heck I'm talking about if you didn't have me for grade 10. And so we're going to work through a few of these examples. So here we go. So I think the easiest thing for me to do this is going to be to I'm going to write out the cookbook algorithm, and then we're going to practice a bunch of these examples to get good at it. So I'm going to solve one as an example, and then we'll write that cookbook algorithm. So imagine that we had this exact right triangle right here, but we were given a bit more information. Imagine that we said, okay, this is going to be 60 degrees, and I knew that this side up here was 15 meters, and I wanted to say, let's say, solve for the base of this triangle. So here's how we're going to do it. First thing that we're going to do, and again, just stay tuned, we're going to write the cookbook recipe in a second. So we're going to put a theta on the angle we know, or the angle we want to know, but not on the right angle. I'm not allowed to use the right angle as my theta. Right angle has to be there, but I'm not allowed to use it as my theta. So I'm going to drop my theta on the angle that I know or that I want to know. Then I'm going to label off the sides, H, O, and A. So H stands for hypotenuse, so it's obviously got to be on the hypotenuse. O is the side that's opposite to theta, so I'm going to call this O. And A is the adjacent side, it's what's left over, so that's going to be side A. So I'm going to write out HOA theta, and I'm going to fill in all of the bits of information that I have. So I know my H, it's 15. O, well, in this case, O is not very interesting. It doesn't have a known value. It doesn't have a variable that I'm interested in. So it's actually not going to get to play on this particular round. And then A, well, it's X, and that's relevant. And then theta is 60 degrees. So I have an A and H and a theta. So we will probably remember this acronym, SOHCAHTOA. So SOHCAHTOA is what is going to help us decide what primary trig ratio we're going to use. So in this case, I don't have an O, so I immediately can say, well, I can't use sine because it's got this O right here, so I'm going to eliminate that. And tan has an O, so I can't use that. And so I have A and I have H, so that means I'm going to have to use cosine. And what I meant earlier when I said that I want to have sine, cos, or tan of theta equals first letter over second letter, this is where this comes in. I have cos because of this C. So I'm going to have the cosine of theta is equal to, and what I mean by first letter over second letter, that refers to SOHCAHTOA. So first letter in SOHCAHTOA is going to be A. So it's going to be A over the second letter, which is H. So that SOHCAHTOA helps us set up exactly what order things go in here. So now I'm going to fill in the values that I have. So I know that theta is 60 degrees. I know A is going to be X, and I know that H is going to be 15. So I'm going to fill that in. So we're going to have the cosine of 60 is going to be equal to A, which in this case is X, over H, which in this case is 15. So this is a lot of the work. If I were giving you a test on this stuff, just getting this set up would be worth probably half of the marks of the question. So here I am. I need to solve for X. And so we can see that currently X is being divided by 15. So if I want to solve, I wanted to get rid of everything that's happening to the X. So I'm going to have to multiply both sides by 15, multiply by 15. These 15s are going to go away. I'm going to be left with X is equal to 15 times the cosine of 60 degrees. And I mean, that's obviously beyond what I can do in my head, so I have to get my calculator out. I am going to remind that when we are doing any trig stuff like this on our calculator, we have to ensure that our calculator is in degrees. Okay, if we do this in radians, we could type it in exactly right, but we're going to get the wrong answer. So I'm going to go over and select degrees to make sure that I'm in the right mode. Now on your own calculator at home, I'm not here to help you. Most of you will have a DRG button, and somewhere on your calculator display there's going to be a little tiny D or a little tiny deg, and it's extremely important that your calculator is in that mode. So I'm in degrees now. I'm going to go ahead and I'm going to type this in. So we're going to have 15 times the cosine of 60. So 15 cos 60, and we're going to find out that X is going to have to then be, obviously, where's my pen? There it is, 7.5, and I don't remember whether I had units on this or not. I did, meters. Good stuff. So I'm going to come back here and say this is 7.5 meters. Okay, so there is a worked out example. I'm going to stop this now and then start up again, and I'm going to write that cookbook recipe out.